All right. Well, let's get the show on the road anyways. We're going to be recording this so other people can join in later on. So no big deal there. So if you're used to JavaScript, we're going to go over a bit of JavaScript and a bit of Python today. But just because I use JavaScript on a day-to-day, I'm much more familiar with how to use the syntax of it. Python, I'm familiar with the concepts and I've used it, but it's been some years since I've last used it. So I'd have to Google for some of the syntax funness. We do have some Python code to get to later. For now, let's go over JavaScript. So let's say that I have a function that is just return object. It takes a parameter of prop, and then it just returns prop. No problem, right? So if we did console.log 3, meant to say 3, I've typed the wrong letter twice now, and I did console log return object 3, it would do the same thing. I should probably call it return item because 3 isn't really an object. So, too used to those Mac key commands. There we go. So this is pretty straightforward, does the same thing both times. What you may not know though is that you can pass functions as a property. So let's say that instead of something like this, we have fn that we pass and then prop. Instead, we could do something like this. Oh goodness, the demo gods are not on my side today. That's quite all right. We can do something like this, return item, then we're passing the function of console.log and the number 3. When we do so, we're calling the function that's passed as the first parameter and the property that's passed in the second parameter into themselves. So say we open up Chrome, we open up our dev tools. Ooh, console logs from google.com. So if we copy and paste this, you can see that 3 is printed 2 times. It's no problem. That's because console.log is itself a function. This function happens to be implemented in native code, which is all the same to us. We handle it the same either way. But we're able to do things with this value because functions are no different than passing objects, no different than passing numbers. It's just a value under the hood. So we can say console.log. Well, hang on. I'm going to keep it a little bit simpler than this. Because I'm passing in a function and I'm passing in a prop, what I can do is I can pass in an arrow function to this fn property. So I can say something like return item val, and I'm just going to return val plus 1, and then I'm going to pass the number 10. You can see that 11 is returned. That's because this function is then passed to fn with the prop in order to make 11. So another way to rewrite this would be const add 1 equals val plus 1 and return item add 1 10. Right, so this is pretty straightforward. And granted, the syntax might be a little confusing here because we're mixing arrow functions and standard functions. So if you're not clear, please feel free to either ask questions, leave a comment in the comment section. I'm going to be interacting either way. So we're defining a constant, add 1, and we're able to pass that to the function as a parameter. As JavaScript developers, we might be really familiar with this concept because of the concept of callbacks. So for example, if you use a lot of Node-style APIs, like Node.fs, you'll see that a lot of their APIs include things like exists. You pass a function as the second argument for a callback. So in this code, you have fs.exists. This won't run because it's in the browser, but if we ran this on Node, it would run just fine. Although it seems that exists is depreciated, so something like stat might work a bit better. But we're going to keep exists just for demo purposes. So in this case, fs.exist would be implemented something like path fn, and then we'd call fn with something of true or false. And that's a very, very, very basic of how exists might be implemented. You're accepting a callback. We can actually rename that to callback because it's just the name of the property. And we're able to pass values to that callback. So exists here becomes what we call here. So this pattern might be a bit familiar to JavaScript developers. The pattern that might be a bit more obscure is returning functions. So let's say that I had function return console, and I took prop. That's not the right syntax. Caught myself there. I use JavaScript every day, yet I still got thrown off. What I can do here is I can return an arrow function that's console.log prop. So this is a bit interesting. I shouldn't have added a semicolon there. That's not valid either. Oh well. So if I do return console test, you'll notice that it's just a function that's returned. That's because we're pre-providing the value of prop down into this console log, and there we have it. So we can actually call this. We can do return console test, and then we can add another set of braces to call it. So that calls console.log test because we're returning a function. Alternatively, we could do const console test equals return console test, and then we can run console test as its own function. And that's again because functions are inherently values. This is true for most all programming languages, and in fact some programming languages functions are the only values. I'm not exactly an expert in Haskell, but I do know that that is one of the defining properties, is that you utilize only functions in order to define properties, stuff like that. So very fond of functions. Ed, I'm very fond of functions too, and I'm very fond of you for joining us. I appreciate you. So what we can do, I realize if you're going to be fond of functions, this is going to be a good stream for you, because I'm going to say that word a lot. It's great. So we can actually do some interesting things here. We can take functions as properties and return functions. Ed, even when there's no audience, you're still here to entertain. I so deeply appreciate you being here. So because we can take functions and kind of play with them inside of other functions, we can do some very interesting things. We can do something like function do a thing, because that's a good function name, right? I'd say that's a good function name. We can do fn, and we can do args. And here we can return an arrow function, which is what this is called. This is also often called a lambda function. Because we're not assigning it to a variable, it's anonymous in that it's just acting as a value here. It's not actually acting as a variable or anything like that, which can be useful, especially for defining something inline. And then we can apply fn and args. This spread operator just says if it's an array, spread it into multiple items. And that's it. So now we could do a thing. We could pass console.log, and then we could pass an array of 1, 2, 3, 4, 5. That will give us a function in return. Thank you, Ed. Thank you for reminding me. I've just done that whole stream with far too small of a window. I'm sorry about that, y'all. I often forget this. I'm sitting in front of a massive, 4K monitor, and, I forget, weirdly, that you can't see that super well in compressed 1080p video. So, we are returning an arrow function. The flex. I mean, it's not even a 4K monitor. It's like a 1440 monitor, but it to me, that's 4K. Like, it's astonishingly high quality for me. That's what I'm saying. Any more high quality, and then I can't start seeing it. So let's actually look through some of our previous code, because I've goofed it up so bad. So return item, we take a function, we take a property, we apply that property to a function. Console.log3 is essentially the same thing as return item console log 3. You can see that 3 is printed twice. It's because console log is a value that we're applying to the fn prop, and then we're passing the prop to that. We're also able to do like return item. If we define add1 as an arrow function that we assign to add1, we can also do things like return item add1 and 10, because we're returning the return value from function, which in this case is this. So we are returning the return of val plus 1, and we're providing val with the property of 10. So that's why we get 11 there. Let's see here. What else did I go through? We also had the return console. Interesting. So you must, in order to use functions inside of other functions, you must pass it as a parameter. Not necessarily. That's actually a really great question, and something I was going to get to, but you're actually kind of on track. I should be pointing that out probably sooner. So if I did function let's do function call other functions, right? We can either pass it as a function, so we could do like functions, and that could be an array, and we could do functions.for each function, and then we could call that, right? So we could say call other functions, and we could go, actually, hang on, I'm going to redefine this. I'm going to pass the number or the string hello world. So now I could do call other functions with an array of console.log, console.warn, and console.error. These are 3 separate functions that I'm passing as an array. We're then calling the for each method on the array prototype, and then we're passing an arrow function so that each one of these, so console.log is first up, we're passing it with hello world, console.log is second, then console.error, and you can see that it runs all 3 of them, right? So you can pass it as a parameter, but we could also instead replace functions const fns as an array inside of the function, and then if we call other functions, it does the same thing, right? So you have a ton of flexibility. You'll notice that this is super unusual in most code bases. I'm passing an array of functions, right? So like if we actually look at what that type is, it is an array of 3 different types of functions, and that's really, if you leave this stream with any information, if you leave this video and you're like, I didn't understand like 3/4 of what he said, please let me know if I at least conveyed the information that functions are just normal values that you can happen to call. There's no difference between this and what's above it. The only difference is what the containing values are able to do. I can't call an object, but I can call a function, and that's really the only difference. A great example. So if I do console.log, actually we'll start with objects. So if I look under the Mozilla Developer Network for object.prototype, if you're familiar with how the prototype system works in JavaScript, you'll know that you can have functions on the prototype so that every object, whether it's this object or this object or this object, they will always... I know, Ed, I know, but I am trying to explain what prototypes are able to do. So And prototypes are kind of unique to JavaScript, but in other languages, they're implemented in different ways. So notice how all of these objects, I'm storing 3 objects into an array. I'll call it const object array. Notice that all of these objects contain different values. But if I do object array 0, I can still call some methods on it. Those methods are functions that will operate on any... this document is not helping me greatly. I just want to see what the prototype methods are. But I'm able to run functions on all of these, all the prototypes. So if I do object array dot toString, I can see that that's not super useful, but I'm able to run the toString on all of them. Object dot prototype dot mdn. Constructor method, here we go. Dot toString dot value of. Will value of be good enough? Yeah. So I'm able to call value of on all of these functions, even though they're just different objects. So even though they're different objects, I'm able to use this value of. Same thing with strings. So string 1, 2, 3, I can call 2 lowercase. I can call string ABC or ABC dot 2 lowercase. So all strings have something like string dot prototype dot 2 lowercase. So any string that you make, yeah, it's very, very, very weird. JavaScript is a very odd language, and the more you learn about the prototype system, the more it confuses you. And yet it's still super useful, because here's a great example. If I do string.prototype.123 equals 123. Oh, it didn't like that. 1, 2, 3. There we go. If I did 1, 2, 3, well, okay, I'll do hello world dot 1, 2, 3. You can see that now I have this this property on every single string. So it's weird because you can add on to the base functionality of any string, but that's also why it's kind of useful. So it's an interesting mix. Languages don't tend to allow much extension to the inherited base type, but JavaScript is one of those languages that just says, by golly, you're in control. So what you might not be aware of, though, is that functions are objects as well. No, wait. I want to do function prototype mdn. So functions also have their own methods to them. So if I do const, well, actually, we'll do add one, right? So we remember const add one. Oh no, I knew that. Thanks, Ed. Appreciate it, buddy. So we defined add one just as a generic function that said val. That's not what I wanted to do. That just said value, add one to the passed in value. Well, we can actually do add one dot name, which seems rather simplistic, but what happens if I did function get fn name return fn.name. So now I could say get fn name of add one. Ta-da! That's kind of cool because here, fn, there's no definition to add one. There's no reference to it. The only reference is that I'm passing in a value. We also have, what else do we have on here? We have call. I don't really want to get into call because that gets into binding. Length specifies the number of arguments defined by the function. Let's do add one dot length. We only have one argument. One shows up. That's pretty cool. I don't know. That's neat. So you could do things like if function.length equals 2, do something. If it equals 1, do something else. I don't know if I'd recommend doing that in production, but you could do that. You could do it. So functions are just values. They have their own prototype system. They have their own equality. They have their own their functions, their values, right? Like you can pass them, you can return them, you can assign them to variables. Anytime you do something like this, that's assigning the value that's here to the variable that's here. Again, sounds super obvious. But what happens if you start mixing those concepts together? So let's say that I have function append functions, right? So I want to have an array of functions, and for each value in that function, I want to pass it to the next. So I can do like for let I equal 0, let's hear I less than fn's dot length. I forgot how to do a for loop there. You caught me. So I'll do basically a reducer, but by hand. So I'm saying let the previous value equal nothing, and then functions, we're passing the previous value, and then we can actually say the previous value equals fn's dot previous. So now we can do things like, let's find some things here. Our first function, we won't give any of these functions a name. We can say something like return 10. Fn's is, oh, well, that's because I messed that up, right? So function is an array, so I need to pass the index of that array. And then at the very end, we probably want to return previous. Hang on, we'll rerun that so that we have a pretty clean go. All right, so now we can say the first function will return 10, the second one will add 20, and then we can say number, what is it, carcode at? I think it's string.carcode at. String.car from carcode num. Probably going to want to boost that. Yeah, that's good enough. I think it's actually like 50 that we're looking for. 60. Yeah, F. It's F in chats. Let's get some Fs in chat. And then we could say string. Oh, whoops. Then we could say car dot repeat 10, because that's how many times it should be in chat. Thank you, Ed. Right on time. Or actually, we'll make it a hexadecimal. So we'll repeat that 6 times, and then we'll say color. We'll do color. I don't know why we're going to leave it at that though. And then we'll say append that value. There we go. Look at that. That's kind of cool, if you ask me. It not super useful in this instance, but what we can do, and the reason why this type of thing is so powerful, is because we can remove all of these functions into their own declarations. So we could say const add 10, or const give 10. I don't know why you'd make that a function, but you could. And then you could do const add 60. Sixth, yes. And then you could say const give car code. And then you could say const repeat 6. Const make hex. And there we have it. Right? So like this example is a bit contrived, and by a bit I mean very contrived. It's a very contrived example. But it allows you to do things like, oh, of course I'm not in my editor, so I can't use multiple cursors. This is the problem with IDEs. You get used to them, and then you're in big trouble once you don't have them anymore. So something like this, right? Like this isn't a great example, again, because it's a bit trivial. But if I needed to do any of these functions multiple times and I didn't want to call all of them at the same time, this could be super useful to me. Or even I could do things like, let's say that every single time what was I going to say? Every single time that I want to give a car code, I also want to add 60. So like I have a base number and then I want to add 60 to it from whatever and then turn it into a car code. What we could do is we could say const give car code plus 60. And then we'll have num. And now what we can say is append functions, give 60, num. And then we can say something like, what's this? Give car code num. So we could say plus 6. Give car code plus 6. I didn't realize the implications of having arrays of functions. How popular are they? In terms of organization, it seems like a blessing to have a set of functions for a particular topic and then only access the ones you want. How popular are they? Not. That's not true. That's not true at all. Having arrays of functions are powerful. They're a very, very, very powerful abstraction, and they're used in some very powerful ways. They're just not super common in a lot of code bases. And what you're pointing out is exactly correct. In terms of organization, just being able to have a set of functions and have them interop with each other. This is generally called currying, when you take a function, modify another function, and then utilize that value. That's where the concept of functional programming comes into play. When you start getting used to dealing with functions, when you start writing code that is only using functions, that's where you have like a ton of power and a ton of capability. It's not super common, but that's typically because there's different patterns that most people tend to prefer. So it's kind of a mixed bag. But yes, I agree with you. That's exactly what I'm trying to demonstrate, is that it's super powerful and you can do a lot with it. So, for example, what did I just do? I added a variable here that shouldn't have been. If I do give car code plus 60, and I pass the number 10, why didn't it? Oh, because it was, why did I say give 60? It's add 60. You know what, Google, I'm getting real sick of you're proving me to not work very well under pressure. I'm not very appreciative of that, you know? I'm over here doing live streams all the time. You just want to give me sass. That's all you are, aren't you? You're just a sassy person. Going smooth. Exactly. So now I can say give car plus 60, 10. And it's going to give me a function, because if you notice at the very end here, instead of returning one arrow function, I returned a lambda, which returned another lambda, which returns a value. So now, let's say that I needed to hard code this f. Like, let's say instead of add 60, I went to the server and I grabbed a random number, because, like, let's say my application had a really, really dedicated requirement to make a random number. You don't tend to want to trust a client for that. You usually want to, well, I say that, but you do trust a client many times. But for like super, super, super secure access, you usually want to have like some type of hardware randomization. So let's say that add 60 added a random number in here, and you wanted to go grab from the server every single time. Well, now, instead of instead of having to do function, blah, 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 because we've defined all these functions already, I could just say const give random string equals that. And now every time that I need to be given a random string, I could just do give random string function, right? So because I returned it as a function here, I'm able to now kind of generalize my code a bit more. And this is why, Ed, to answer your question, this is why having arrays of functions isn't super common, because I'm not going to pretend this code is kind of hard to read. If you're not familiar with functions as values, this code isn't immediately clear what's happening. But let's say that I have a large-scale application, something like 40,000, 100,000 lines of code, which isn't a large scale, it's more of a medium-scale application. Let's say that I have a fairly sizable database, or not database, but a code base, right? Being able to provide this level of abstraction and just hide it in some utils.js file and then export from there, you can hide a lot of abstraction, which can reduce code across your code base, just having one file look like this, and have some of this functional utility. So it's super powerful when you're able to utilize it. It's another good example. Functions, returning functions. Yeah, so just a quick recap. Oh, I don't know why I did that. That was a goof moment. I just defined an arrow function of an arrow function. This is a value. This is a value. We're returning this value from this value, which is assigned to a variable. So if I did hello function, you'll see that it's returning this. And then if I call it a second time, it's returning this. Does that make any sense? So yays and nays, Corbin, go back, explain some things. We have a few more viewers now, so I apologize if I'm seeming like I'm jumping around a little bit. It does. Yay, cool. Awesome. So let's look at some Python code. Who doesn't like Python code? I like Python code. So if you're not familiar with Python, def is like the version of function. Don't worry, it's going to be a lot simpler just because my understanding, well, I understand Python plenty well, but I'm not going to subjugate anyone right now to, what's it called? Oh man, I was so proud of knowing this not even a year ago. I don't remember. List comprehensions, that's what it is. I'm not going to subjugate it here, anyone, to list comprehensions. Although I can, if anyone wants to see some awesome, terrible list comprehension code, let me know. I'll make it happen. Again, the right hand shrug. All right. So, it's supposed to be a flex. It looks like a very, I don't understand the joke. This is just going to be a commonality across all of my streams. Ed makes some Twitch meme, and then I just don't get it. All right. So, I love how you can't even see the emote properly on the screen. Look, it's a shrug, an arm thingy. See? Yeah. So, what is Pog? I know. See, I feel so foolish for asking that now, because now I'm so ingrained in the Pog culture that I know what's up. All right. So here we're defining a function. This is very similar to in JavaScript, like function print the value. Right? Very similar. Just different syntax. So here we're passing the hello world into val, then print is calling it. Print is kind of like console log in JavaScript. However, just like JavaScript, you can pass a function and then call the argument that way. So hello world is arg, you pass print, and then you're applying print with arg, right? And then instead of arrow functions, you have what are called lambdas in Python. So you have print the value, lambda val print. So here it's effectively saying, let me convert that to JavaScript-like syntax. Const equals val. Exact same thing. Like lambda is just, when I had mentioned that it's an anonymous function, it's that same concept of just you're not assigning, you can assign it to a value because again, even in Python, just as JavaScript, functions are just values. I realize I said just there. That's because I don't know why. I just did. But you can assign functions values even when they're anonymous or lambda. Lambda comes from the term lambda calculus. I've never taken a calculus course, so I'm not going to sit here and pretend to know what I'm talking about in terms of calculus. So if you want to inform me of all the good lambda calculus terminology, let me know. I say that, but then my friend who is a very good math nerd is going to join, and then I'm going to regret this. It's going to turn into, that's actually called this. And then I'm going to go, oh no, I look foolish as usual. So, if you're familiar, if you're not, that's okay. I'm going to go over it anyways. But arrays have some functions as of ECMAScript 6. So we have, let's just make a few values in this array here. Here. Oh my goodness. Keep hitting the wrong things. We'll do 1, 10, 100, 56, 78, 49, and then 42, because 42 is a good number. So we'll assign this to a variable. We'll do let vals. So there are 3 functions that I want to go over today. I'm kind of giving away some spoilers off to the side here, but they are filter, for each, and map. So we have vals dot for each. So this is just saying for each of these values, do a thing. So I will say for each of them console.log val. There we have it. So for each of them, I do want to mention, because console log is already a function, we don't need to pass this. We could instead say that. But then when you do the for each, it's going to pass all 3. So if you look at the MDN docs, for array prototype dot for each, you'll see that 3 items are passed to that function. You have your current value, which is the first item. You have your index. I don't know why I've gone to the, I don't even know what language this is, but a different translation of the site. But there's a current value, there's the index, and then there's the full array, which is why we get 0, 1, 2, 3, 4, 5, 6, because that is the index, which is the second item that is passed to this function. And then the first item is the full array. So this is valid JavaScript because this is just a function. But if you only wanted the first item, you'd have to filter it down using this. But that's for each. There's also vals.filter, which is like, I only want a limited number. When this function returns true, give me it. So if I just say true, it'll give me the whole array. If I say false, it'll give me none of the array. But then if I do something like val is less than 70, it will only give me the values that are less than 70 in that array, because this is conditionally true based on whether each of the items, so like 1 is less than 70, 10 is, but 100 isn't, that is, that isn't, that is, right? And then finally, there's also vals.map. So map says for each of these items, run this function and then return that value. So again, if I did true, you could see that it returns true for all of them. If I put in 100, it would make all of the values 100, but I can also say like val plus 100. So this says for each of the items, just add 100 to it, right? So that's map, filter, and for each. But what if I told you that you could write each of these in JavaScript and in Python? Like, so instead of vals.map, you would have like map, vals, and then the function, right? that sounds like a cool idea. So let's do that. Let's go through the Python code first, just because LOL. And then let's go through the JavaScript code second, because that's where the actual like brain teaser of like me suggesting that you should do that comes into play. All right. So let's do for each first. Small code, tiny code. Range is. Why did I have to write this in such a Python-y way? It's like the correct way to write it in Python, but then it doesn't map super well to JavaScript. Essentially what this is saying, range gives us an array of like 0, 1, 2, all the way up to the length. And then it says for number in blank. So for each of these items, it's a basic for loop with the index. So it's just saying for each index, here. Right? So for each index in the array length, call the callback, the second function, with 3 items: the current value, the index, and the full array. So in Python, you can't just remove parameters. If I called this with only one parameter defined, it would throw an error and go, no, you're a terrible person. Please add the other 2 back. So all right, I did. But I'm just using underscores to denote that we are not actually using those values. So here, we're passing a lambda, which is again similar to for each car. Pretty similar, right? Good stuff. So we're saying print car for each of the cars. Ta-da. Pretty straightforward. Let's do map. Map, yes. So map, here we're saying give us a blank array before the function. And then for each, I'm going to rename this to index again, because darn it, that's what the name should have been. Here, I'm just saying whatever the value of the return from this callback is, assign it to a new variable called newVal, and then append that value to the array. So it's saying for each of the items, call this lambda, this anonymous function, whatever the returned value is, then assign it to that index on this, assign that value to this array, and then return that array. So in this case, Ford, Volvo, BMW, we're getting lang, which is basically saying car.length in JavaScript. And we're saying, give us the length of all these strings. So if I were to copy this and put it into our handy dandy notebook, and by notebook I mean Python, then we could say, please tell me this works. It doesn't work. There we go. That works. I'm used to a special Python version that has all these weird commands. But you can see we're actually getting the length of each of these strings. It works. That's pretty cool. Then finally, there's filter. Filter adds on to this a little bit. What it does is it takes that callback. Again, instead of num, we're going to say index, because it's a much better variable name. For each of the functions that we call, if it's true, then we append it. If it's not true, then we don't append it, and then we return that array. So what we're saying here is, if the car manufacturer is Ford, say yes. If it's not, say no. And then if it's yes, add it to the finalized array that's returned. If it's not, don't do that. That's pretty straightforward. So here, I'm going to copy it. I'm going to paste it. I bet you're going to guess what the results are. I bet there we go. It's Ford. Ford always wins. You can't beat Ford. I'm sorry, BMW. That's probably the most controversial. I've lost 2 viewers because of that statement. Shame on me. That's funny. I'm just kidding. I don't actually like Ford. That's the best part. I don't have any allegiances to most cars manufacturers. Although I think if I keep saying that actually might make the viewership go lower. Ed just leaves the chat, and then it's just me. But something I want to point out is that all of these kind of add on to each other. So notice that it's 3 lines. Notice that it's 6 lines. And then notice that it's 7 lines. If you look at the code, they're kind of similar. They got kind of the same vibe, right? Like, they all take the 3 same arguments. Yeah, that's it. They all, right? So what I could actually do is in map, I could say, I mean, I couldn't because, yes, I could. I could say array, well, for each array, and then I could pass, well, no, I couldn't. I could say, let's see here. I'm good, but I'm not that good. Will this work? Is this valid? That's valid. Yeah, okay. Boop. So I could say val index array, and then val index array, and then boom. Yeah, so that's valid. Why is it throwing an error there? It doesn't like that I have this braces thing. Oh, that's because braces are oh, golly. Okay. Look, I don't know. I don't know what's wrong here, but effectively this is valid. I'd have to write it. This is where my syntax of Python knowledge goes blank. But you could write each of these using the previous one for the most part. They all have very similar code. We're happy with that though. All right, now onto the JavaScript goodies. Let's look at for each. Ta-da! It's 1 line longer. Actually, it's 2 line longers. Darn you, braces! All right, I forgot something here. There we have it. So we take the array, we take the callback for each of. We're doing a for loop with I, and then we use I to index that value. Same concept. I'm actually not going to run that. Then we have map. Map is very similar. We have, I don't know why I keep missing the arrows there. I'm going to copy that because I have a feeling I missed it later. But what we're saying is we have an array for each of these I items, get the new val from the callback, which is this, and then push that onto the array. And then finally filter is, of course I didn't include an example. That's shameful. Yeah, not only did I not include an example, I forgot the arrow as well. Can't believe it. Car equals Ford. You know, we'll make BMW win this time for once. Just because they cheated. I'm sure it is. So in this case, I also need to change map to filter. So there we have it, right? So we have the array for each I. If it exists, add it to the array. Otherwise, don't. Pretty cool. But even better. So let me back up a second. The prototype system, right? Why use for loops and not do it recursively? Would that make it more functional? Why use for loop but not do it recursively? I'm not sure I follow what you're asking. So for example, what you could do is you could do, yeah, I'm not sure I follow, because all of the like functionality that I'm thinking here would be like, I mean, you could do something like this, where you would say function check and add array I, and then you could say check and add I. So that's something you could do. Is that kind of inline Cowtel? I'm not sure I follow what the question is. Because in this instance, you could add the index, and then that index is then passed to the callback. So like a function that calls itself so long as it meets the conditional. Yeah, you could do that as well. Yeah, and it would be more functional. It's probably not. It's a good point. I just hadn't considered it, to be honest. I think this is like a combination of me trying to like explain some of the code without some of the functional paradigms. But I guess since I started this stream off with the functional paradigms, I could have laid it out that way. So yeah, you totally could. You could say, how would you do that? Array. If array. I don't know why my brain is having such a hard time with this. Function add to array. I don't know why I've done that syntax all wrong. I swear I can type until I get thrown off and get confused. It's probably better to use a loop for performance of JavaScript, so it's not too bad. Yeah, it's probably better for performance and it's a bit easier to read. But you're right, if I am going to talk about functionality, might as well go there. Admittedly, this was kind of an ad hoc stream. Someone had asked me this week about making a stream about functional programming, and I had a very limited set of resources that I had already finished, so I was like, I can probably make some form of stream out of that, but you're right. Let's like dive in. So we'll make I equals to 0 as an early version, and then we will say if array.length. For loops make me feel more readable than a recursive function call. Totally agree. Yeah, and that was kind of the main basis to it, was that it's just more readable. But it is a good question to ask. Yes, if array length is shorter than array length. My mental typos are awesome. I love it. And no. If they're not equal. Right, if it's larger than or equal to, then we will return the array. And then we will say, we'll do array, callback, I, and then we will say, I'm just trying to write one of them for my own justification. At this point, I want to do it, darn it. You've taunted me, and now I have to do it. To call it a challenge. I don't know why I find recursion so hard. I think it's been a while since I've had to do proper recursion. Which makes me feel like less of a developer, but I know I'm not one. So add to array. We'll do cheat. We'll say if. And then we can say if exists, then we will add to array callback I plus 1. Otherwise, add to array right? Yeah, so I'd also have to do new array equals empty array. Okay, I got this. Callback I plus 1. And actually we want to move this, so this will be array. That'll be that. And then that'll be that. So this, I want to say, does the same thing? Maybe? Yeah, that sounds about right. I could be totally off here. I think that does the same thing. Let's find out. I bet it doesn't. I bet I've just completely butchered this. So filter 1, 2, 3 v equals 1. Add to array is not. Oh, it's because I've renamed the array. No, what did I do here? Oh, I have to return new array. There we go. We did it. Yay, that makes me feel much more competent as a developer and not like I'm a sham who shouldn't be doing a live stream. I'm not gonna lie, Cowtel, you really threw me for a loop there. I was like afraid that I wasn't even gonna be able to do it on stream, and like oh, imposter syndrome hit hard for a moment there. I don't like that. That's not good. I'm not pleased with this. Is more functional, I will not deny you. I'm just not pleased with how this has gone. This doesn't look good. And it's probably a lot slower, especially because of the spread operation. So yeah, it's more functional. I just don't know if I would have done it that way. Let's go a little bit deeper, because this can be even more functional, darn it. Because we have constants here. We can make this even more functional, friends. So we can say things like, Ed, are you still in the chat? And if you are you still alive? Because if you are, Ed is one of my designer friends, and he's decided to join for this chat. Perfect response there, buddy. So we can say, boop. No, we don't need braces here. Boom, how's that? How's that? Put that in your functional pipe and smoke it. That's terrible. Declaration or thing expected. What do you mean? Oh, that's because of that. So I think that is as functional as we're going to get. Does that work? It works! Yeah! That's awesome! If anyone doesn't understand what's going on, you're a much developer than I am, and I wrote this code. Let's actually break it up to see what's going on here. Yeah! America! Oh. Golly, this is good. Alright. So what this code is saying... This is... I can't believe I've done this on stream. Cowtel, I blame you. I hope you're still in the stream, because I blame you. So what we're saying here is we're going to start the array off with 0. We're going to have a new array. And essentially, if we've exceeded the length of the array, we're just going to return the finalized array. Bada bing, bada boom. Then we define a function here. And we will get to this function, what it does in a second. But first... we call the callback with the current value of the array, the index, and the array itself. So in this case, we're saying, the same syntax as the prototype. We're able to say, so once we get this value, this will tell us whether something exists or not, right? Because this is the filter. So this tells us whether we should allow it or not. So that immediately executes and passes to this function. This function then says if it exists, we're going to call the filter again with an index of +1. So we're moving down the quote unquote for loop. And we're appending by using this, we're creating a new array with all of the old values and a new value, which is the current index. Otherwise, we call it with the index of +1 plus the old value array without anything else added. So that's it. I swear, if you're on my team and you're watching this stream, which rhymed, that was a good rhyme, but if you submit a pull request like this, I'm not going to accept it. That is not ideal. I'm not going to lie, because I can't glance at this and figure out what's going on. Good way to toy with functional JavaScript would probably be to make some to-do app or something with React, probably. Yeah, but I didn't want to, which I think is a good reason. No, really, so I think one of the problems with functional programming is that, especially when you're early on, you see things like this, and then you're kind of intimidated, right? You're like, well, shoot, what does this do? Because I'm not going to pretend. I look at this code and I'm intimidated. I'll actually share a gist that I wrote a while ago of a similar project that I did. I wanted to, for one of my old apps, I wanted to test what Semver things were on. Is this it? No. Where is it? I make all sorts of things. Here we go. So I wanted to check which versions of NPM my packages were updated with the major NPM, but I wanted to write it in a completely functional way. So I did. I have an array of function. I reduce those functions. I like have a void promise all. I really go ham on this. But I don't want to write code that way day to day. At least not with JavaScript. Not only because it's arguably non-performant and sometimes, but it's also like difficult to read. It's difficult to parse. The tools aren't especially handled for this. If you use arrow functions all the time, you have issues with your call stack being problematic. If you're doing debugging, so like, and by the way, Caltel, I really don't mean to call you out. I'm not even trying to say that you're making any of these arguments or that you should write code this way. I'm making just general conversation, especially because I've heard the argument from a lot of functional programming purists. I think it's a super powerful tool. I admitted it even earlier on stream when Ed was pointing out that array of functions are super useful. They're incredibly useful. And there are even applications where doing something like this is useful and it's powerful. But it's not how I want to write most code, and I usually have to have some justification for it. And notice that even within this code sample, I'm leaving that slew of comments, even for myself, if I come back to this for whatever reason. But more than that, when you're getting started, one of the problems that I've seen when I've helped people learn programming is they're like, hey, I hear Neko Overflow workshopper list. I don't know if I'm going to like this, but I only say that because I'm always very hesitant on like, yeah, this seems like a really good resource. Yeah, I've seen this before. Currying with JavaScript Currying with JavaScript, they've got all sorts of good stuff here. I know Node schools. They're pretty good. I just happen to not be Node schools. Over React app, I'd learn using test-driven development. Yeah, I'd argue that more because the one reason why I really didn't want to use a framework here is because I've heard super often students will come up and they'll be like, hey, what is this React thing? What is immutability? How do they pertain to one another? Is immutability specific to React? And I really wanted to make sure that whatever I was talking about, I wasn't framing it as you have to do this with React, you have to do this with Angular. And while you can do tutorials on React with functional programming, without doing that, I wanted to showcase that you're not only able to, but you can create useful tools just with functional programming. So yeah, if I turn this into a long form series or even a more sit down recorded session, I'm definitely going to make it probably test driven. That's a good idea. But this is just like a quick walkthrough for folks. So, especially since I had a bunch of people asking me about it. But going back to what I was saying before I got absolutely nerd sniped by Cowtail. Notoriously nerd sniped. Is that arrays have prototypes. You have filter, you have map, and those prototypes can actually be written in JavaScript itself. So within prototypes, this refers to the value of the array. So it's the same code, we just added this for the array. So if I do that, I can now do array dot, I can do 1, 2, 3 dot for each v console dot log v. Assignment to constant variable. Oh, it's because I did const I equals 0. All right, that's fair enough. I'd have to do let. All right. But yeah, so you can even rewrite a lot of JavaScript's like prototype methods, the map, filter, for each. just with a tiny bit of JavaScript. So, yeah. I'm probably going to end the stream relatively soon, just because I think I've exceeded most of what I mentally had planned out for this talk. That const works in for in loops, though. I thought it did, but then it gave me an error. Why did it give me an error? It's not very nice. Unless if I suspect that it's lying to me. Is it lying to me? Hang on, let me try this. Yeah, it doesn't give me an error anymore because that was an index loop. Oh, yes, that's why. Okay, I'm sorry. You're correct. So if I did for const a of 1, 2, 3. Yeah, you're right. It's because I'm trying to do the assignment there. Because of this line. No, this, I don't know. One of these lines. Hang on. Const a equals 0. Fine. Const w equals 0. Who uses w for an assignment? What happens if I do w plus plus? Yeah, I'm trying to, when you do plus plus, that's a mute. You're not mutating. You're assigning a new value to the variable. That's what's causing the problem. It's because of the plus plus. I'm sure if I just didn't have this plus plus here and I replace it with something, I could use const here. We can abuse the for loop. In fact, we should write all of our code inside of one for loop. That's my new theory. Hear me out. We write functional code. I've gone mad. We write functional code. Yes. That is an interesting thing about const. You are correct. That is because we are mutating. Actually, yeah, well, let's get into that. Const array equals blank. You would assume you can't do something like this. And you'd assume correctly. But you can change the values within. Which is interesting, because I put the word const there. And const usually means constant. So you'd assume that you can't change it. Why can you? Great question. And it's actually not a question in this case. This is more of an information that Cowtel is trying to let us in on. But it's a question that I get asked a lot when I point it out to new students. And I like pointing it out to new students because it's an important thing to learn. And it's because you're mutating array. You're not replacing array. Let me see. I'm going to pull up Figma. Ed's going to laugh at me. He's going to see some squares. And then oh, wait. Find out next episode on Dragon Ball Z. No, we're going to do it in this episode because it ties in very well with my overarching point. That functions are values. So, Ed, please start laughing because it's going to get funny how bad I am at design. Ed's, again, my design friend. He's allowed to laugh at me. The rest of you aren't. Boom. 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 All right. We have 4 boxes here. We're going to call this RAM because that's what it is internally. Ed, you are familiar with this. You think it's a joke that he's calling it an IDE. When Ed designs things, he turns it into a programming environment. I have not Cowtel, and I should be doing so. And that's why I'm bringing up RAM, and you're getting ahead of me, buddy. I appreciate you, but you're getting ahead of me. So, RAM. You have a limited amount of it in your computer. Everyone does. Even if you have 64 gigs of RAM, well, guess what? That's your limit. It's 64 gigs. And they're usually assigned. You have a block. So you have like 1, 2, 3, 4. This is a bit of an oversimplification. By a bit, I mean a lot of one. But this is the gist of it, right? So when I like to describe them as cubby holes. When you're a kindergartner and you have to like put your stuff in a room and no, am I the only one? All right. Well, they're like cubby holes in that you can put things in them, you can put new things in them, and very importantly, you can put name tags on them. So let's say this num. That's one name tag. Another name tag is going to be fn. Another name tag is going to be, yes, Ed, it is a great handling of the text tool, and I'll expect you to not be mean to me, please. I'd appreciate that. Thank you. Thank you very much. Another function is going to be called, or another RAM slot is going to be called magic string. Yeah, that's a good name, even though I don't like those in my code base, but magic string. And then we'll do, what's the last one? Object val. Or actually, we'll do array. We'll do array val. All right. I'm proud of you. What do you mean? Not suspicious at all. You're clearly just being innocent and very nice. So, each one of these are variables, right? So I'll have 9. Speaking of magic strings, I love magic numbers. I don't love magic anything in my code. If I can avoid it. Oh, wait. Okay. I'm also going to do roboto mono. Look at Mr. Adult over here. I know. So sickening. All right. We're going to have to shrink the text here a bit. So we have a console log there. Magic string is going to be hello world. And then array is going to be an empty array. All right. So let's say that I can only have 4 variables in memory. That would be a very, very, very small device. But we're going to pretend. It's Wondersea land. That's a word. Let it be a word. Just accept that I said the word Wondersea and let that soak in you. And then let the rage boil. All right. So this num is 9. Function is this. Magic string is that. Array val is that. So here's something interesting. When I do code like this num equals 23, what I'm saying is go find the cubbyhole that has the label this num, and you can have multiple labels. So actually, I'll get to that. But you go look for the cubbyhole and replace entirely, like delete the old value and put a new value in, right? But when I say something like array val 0 equals 23, what I'm saying is go find the 0th index and put it in there. I'm not saying to replace the array. I'm not saying to delete the array. So what I'm doing is something called mutating. Because I have not changed the overall value, because this object is still the same object and therefore has the same reference, which I'll touch on in a second, I'm saying that I want to take the existing value. I don't want to change the cubbyhole. I want to just change the value that's in there. Because somewhere under the hood, when you create a new value, when you do something like this num equals 1, what you're kind of really saying is you're saying, okay, I have a space open in number 2. What I'm going to do is I'm going to move this num to something else. I'm going to change that value of that space to 1, and then I'm going to delete the old value. And that's because you're changing the assignment to the variable. You're creating a new reference. You're creating a new spot in memory. And that reference is this little cubbyhole. You're just changing the label of which memory address you're assigning things in. Now with arrays, you usually predetermine the length of the array, at least in most languages. JavaScript, you don't. But in most languages, you can't add or remove number of items from an array for this exact reason. That's when like vectors come into play, stuff like that. But what you're saying here is instead of creating a new cubbyhole and then putting the new value in the cubbyhole and all that stuff, I just want to take the existing cubbyhole and modify the data that's there. Now, you can't say do that with a number. You can't do that from a... Well, I'm getting a little ahead of myself because I'm saying you can't do it from an array to an object, but I'm sure if you were really tricky, you could, because under the hood, arrays are just objects. But for very broad speaking, you can't just magically change an array to an object without changing the reference. And that's really important to keep in mind. The reference is the part in memory, the location in memory that you are storing a variable. So when I do something like array.pop and I remove an item from the array, that's mutating. When I do array equals 1, that's trying to reassign or address the array. So it's trying to move the variable to something else. Realize I'm stuttering a little bit. So most functional code, what's called pure functional code, is non-mutable. So you don't ever want to mutate an item in RAM. You never want to say that I'm in the middle of a function, something like that. I never want to go array.pop or array.push or array.0, whatever, because that's mutable. What you usually want to do is, because most computers have a lot of memory nowadays, and also this is very, very important, because you know that there may be other code that is looking at array value, you want to always create, at least in pure functional world, this isn't always the case, and there I will explain when you don't want to do this. You always want to copy into a new item, and then you can call that the same thing, call that whatever you want, but you always want to make a copy whenever you're making changes. So instead of array.push 3, you would do something like spread array or array.concat 3. And what this does is it creates a new object in memory, and in that new object in memory adds that new value. So you're not changing array val. If I go to array, you can see that 3 isn't added at all because I'm returning a new item. Yeah, exactly. So that's a bit of technical terminology, especially if you're only familiar with JavaScript. But yes, you are correct. You are copying all of the existing data based on the memory. So what is a great example of when this becomes a problem? Console.log, interestingly. So one of the things that I tell a lot of new students when you get into JavaScript is that you have to be really careful about trusting console.log because it can lie to you. So if I've never been able to find a code snippet to recreate this accurately. So if someone finds something, please send it to me so that I can use it when I'm teaching, because it drives me frustrated to not be able to have a code sample. But what you can say is you can say something like set timeout. Oh goodness, stop hitting the enter key. Come on, Corbett. So you can say set timeout console.log. I love console.log. It has never lied to me. I love it. But console.log can lie to you. So let's say array. We'll have array equals new array. Oh my goodness. Where's Google? Let me refresh the page so that I can undo all this mess. So if I do let array equals new array, and I do a set timeout of console log array of, let's say, 300 milliseconds, and I do a set timeout of array.push, I would be really impressed if this showcased the problem. 32, also with 300 milliseconds, and then I did, 200 milliseconds, and then I did an array push of 301. What we should see is, if you look at the timing operation, what we should see is array 32. But if I run this, and sure enough, it's going to show the right thing. There are some instances where you can mutate the value here, and it will update the console log. So your console log is not accurate to the time that it ran. It is accurate to the time that you see it, which is a bit different. It's really, really hard to demonstrate but there are some very convoluted cases where console log does not print out the accurate number for very similar reasons to mutating variable. And in that same way, if you have a timing mishap with your variable that is watched by more than one function, your values can change and it can cause some instability in your system. And one of the primary selling points of both immutable coding and functional programming, usually they go hand in hand, is that you have a sense of stability in your code that is not typically there because of those types of mutations. Now, I will mention that even within most of the immutable code bases I've been in, there is some exception for local mutability. So for example, this is an example of local mutability in this filter or in this map, where we never expose return val outside of this function, and as a result, we allow ourselves to mutate within it. One of the downsides that is typically associated with immutability is that there tends to be a bit longer times to process things, especially with arrays that have lengthy values. And the reason for that is because, as you can imagine, I only have 4 slots open in this example computer. Would you say that's more so an issue with the set timeout executing whenever it feels like, rather than an issue with the console log itself? It's not. It's not a bug with console log. It's a bug with your code. It's the bug isn't with console log. It's that there's no way of console log knowing when something is mutated, because JavaScript is so freeform you can mutate anything at any time, and as a result, console log just has a behavior. But it is a well-known behavior. So like, if you look here, it's a wrong value of console log. It's because the log is delayed until Chrome has time to do it. So as you point out, it's just when the cycle allows you to. And that's part of the blessing and the curse of the event loop in JavaScript. Is a good friend, it hangs out with a bad... Yes, console log is a good friend that just hangs out with a bunch of bad groups of friends. And those bad friends can influence him to lie. Very true, very true. Yeah, so the event loop is a blessing and a curse. If you're not familiar with what the event loop is, that's definitely going to have to be a next time on Dragon Ball Z type thing. Because that is a whole thing on its own. One of the videos that I would recommend is this video. It's a little bit old now, but it's still super, super relevant. It is What the Heck is the Event Loop Anyways by Philip Roberts. Amazing talk that explains things phenomenally. So if you are not familiar, go check that out 100%, because it explains what Cowtail and I are talking about, where the event loop allows for asynchronicity, stuff like that. Do you stream daily, weekly, on a schedule? I do indeed. I stream at least once a week on Thursdays, 4 p.m. Pacific time to 6 p.m. Pacific time. At least I try to make the streams about that long, so I do stream at least once a week. If you follow me on Twitter, and I will link that, or if you follow me on, if you either follow me on Twitter or you follow the blog that I help run on Twitter, we post updates, schedule updates in case if we do a weekend stream every now and then. I did a stream this Tuesday, which is probably where our viewership is a little bit lower. People might be unaware that this stream is happening because I had already done a stream this week, so I do stream on a regular schedule. And then some. So, where was I? Oh, immutability. Why is immutability often associated with higher memory allocation and potentially slower times? The example can be shown here. Let's say that I have a piece of code 3 times. I have array val equals 1, 2, 3. Array val equals 2, 3, 4, and we'll leave it at that. Well, the problem here is that in order for this to happen, I have to copy all of this array all the way over, and then I have to let memory clean up the old one, and then I have to go all the way over, and then all the way over and update that as well. That's not bad for a small array. It's not bad at all. In fact, you probably, if you timed it, you'd have to time it in like nanoseconds. It would be so fast you wouldn't even know it. But when you have arrays that have 100,000, 200,000 items in them. And if you're dealing with databases, that's nothing, a tiny amount of data. At that point, you have a different set of problems. You need to start paginating and you need to start doing some other things. But if you're doing server-side data with a large collection set of data, or you're doing data analytics, you're doing anything with a large set of data, especially arrays, you're going to find yourself with a problem of having to deal with this constraint of not being able to mutate. So it's kind of a mixed bag. You utilize it where it's applicable, or at least I utilize it where it's applicable, and then I feel free to mutate locally, do whatever performance speedups I need to. All those. Exactly. That is actually a fantastic point. All of those nanoseconds do eventually become milliseconds. Those milliseconds eventually become seconds, and eventually your user will start noticing. Optimization isn't for naught, but it can, I don't want to say that performance is the number one thing to worry about, because obviously there's concerns with feature set, and there's issues with code readability and management. So there's a lot of different things to take into consideration, but to throw out the baby with the bathwater and to not worry about performance at all leads to some very problematic use cases oftentimes. So it's a great point to point out that those nanoseconds eventually grow over time. So, and especially if you're running on a serverless cloud like AWS or Heroku or Azure, you're going to be paying for those nanoseconds. And if you let your process hang for a little too long, every 100,000 users that you get, or maybe more realistically, every 1,000 users you get is going to cost you that much more. So it's always important to optimize. And it's why immutability absolutely has its uses. And it's a super useful tool, but like all tools, it's not universally applicable. So, yeah. Luckily, there's a lot of tools that are out there to help you. There's, there's Immutable.js, which is, I want to say that's a Facebook project. Yeah. Immutable.js has a lot of stuff out there for you that allows you to do some very performant things without allowing mutations in your code. There's all sorts of stuff you can utilize. Yeah. I'm trying to think here. What else? I feel like I've given 4 or 5 of my classic, like the spiels that I give all the students that I help teach. Like, I feel like I've given 4 or 5 of those in 1 hour, which is making some good progress. Does anyone else have any questions, comments, things they'd like to point out? Optimizations, places that I'm wrong? I can give a good use case for when immutability is really important. So, have I mentioned Haskell? Okay. I've mentioned that Haskell exists. That said, I do not know Haskell. Haskell, I understand, has limitations, like there's no real concept of variables as I understand it. But I don't know enough about Haskell to really have an informed conversation regarding what the limitations are, what the improvements are. I understand that it's mathematically provable, like you're essentially writing proofs for your applications, which leads you to very, very stable applications. But I don't know much more than that. So, admittedly, that's one of my fallings. No one needs to know Haskell beyond its names. It has no mutation, so you can't do anything with it. Oh, man. I need to send that to my Haskell friend. Here, hang on. I'm going to send that, and then I'm going to watch as they, join the stream and start chanting things in the chat. At friend, my chat has something to say to you. All right. So, one of the places that immutability is super important if you aren't using it is global state management. If you're using an application like Redux, you're probably already using immutability anyways, because it will throw My friend sent an angry face. But if you're using an application like Redux, NGRX, any form of Flux-based store, they typically have guards in place during development mode that'll say, hey, you mutated a thing. Don't do that. So it's a good safeguard, and there are very good reasons for it, because it goes back to what I was saying. If you mutate an object that multiple things are watching, you have no idea of knowing if something should have been mutated or not, and when something was mutated. So having a large-scale store, like use Reducer in React, if you have like all your application looking at the store and you're starting to mutate it here and there in random ways, that's not good. That's not good, because it leads to a very high sense of instability. So, yeah. All right, gang. I am fresh out of ideas for what to talk about. Does anyone else have anything else? Questions, comments? I know there are people who aren't able to be here today who'd asked me to make this stream. Google, I wasn't talking to you. But I know there are people who are going to be watching this as a recorded. So if you have any questions, we're always available on our Discord. The programming site that I help run to help teach people, we have a Discord. So that's available if you want to join that. Always feel free to ping me questions on the Discord. Leave comments, because I review comments, and be like, hey, what did you mean when you said Haskell was bad? I never said that, for the record, but you can ask me why I said that, even though I didn't. The answer is to mess with my friends. The canvas is missing something. You're right, Ed. It is. Where is it? Hang on. We gotta add it. There we go. There we go, buddy. There we go. It's very pixelated, but there you go. There you go. All right. You could use some practical applications, like filtering specific informations from an array of car models or something. I did that, though. I feel like that's a joke. Wait, I really can't tell if you're joking or if you had missed that part of the stream, but I did do that. I feel like I'm being trolled. I feel like that emoji expresses more than I want to like acknowledge, but I also don't know enough about Twitch culture to know. Oh, didn't realize you did that. Yeah. So, you know, it's really small examples, but enough to showcase how lambdas work. I also went over some Python code just to showcase that functions as values. Keep in mind, functions are values. I'm going to keep reiterating that until I'm blue in the face. Just because understanding more like an array of objects defining cards. Yeah, we can do that. But remember, functions are values. No matter, well, I want to say no matter the language, but I'm sure there's going to be one language out there that proves me totally wrong. But in most languages, functions are values. Python is not an exception by any means. But yeah, we can go through that. Let's see here. Where is... I don't know where it went. My code window disappeared. Ooh. It's... For whatever reason, the new tab spams my console, so I often don't use it, but I'm going to use it today. I'm feeling risky. So let's look up some cars. Give me some car details. I don't know that much about cars. Someone hit me with some facts. My notes are just functions, values over and over and over again. I feel like a psychopath. Now you know what it's like to be in my head, buddy. You know what? We're not going to use Cars. We're going to do Cars the movie franchise. How do you feel about that? I just 180'd you. Oh yeah. We're going to do Cars movies. It's going to be an array. We're going to have objects. It's going to be title. Cars. Couldn't get any worse until now. Release date. Oh no, hang on. We're actually going to do Let Cars movie because I'm sure I'm going to throw in some typo. Release date 2006. Catchphrase. Ka-chow. Title. Cars 2. Woo. Release date. Y'all thought I was joking too, didn't you? Catchphrase. I watched all these movies too. That's the worst part. Lightning. Did I misspell that? I didn't. Okay. McQueen. I have no shame. I'm not going to pretend like I'm ashamed of watching these movies. What sort of classes do I teach? Who said I taught classes? So a little bit of context. I do not teach professionally anymore. I did teach a few classes for the UC Davis University, but it was one of their boot camps, and I found it to be immoral, so I stopped doing that. Now I write posts for my website, so I found the experience with the company that was outsourced. I won't name names because why not? But I found the experience so frustrating and like they were stealing money from people that I started kind of doing more one-on-one sessions with people, started the Discord community. So now I've kind of gone and freelanced my teaching of people programming because why not, you know? But yeah, before that, the UC Davis course was teaching full stack development, mostly React and Node. So, but I've done React professionally, Vue professionally, Angular professionally. So I've had I've done native applications. I've done a tiny bit of game dev. What languages am I familiar with? C#, Node, Python, JavaScript, Kotlin. I'm running out. JavaScript is my bread and butter, though. It's what I do on a day-to-day basis. Right now, I'm a front-end engineer for Hilton. I do not speak for them, but I do them right now. Vue. Yes, I love Vue. Vue is probably my favorite of the three, ironically. It's one that I've had the least amount of experience with professionally, yet I love the most, which might be related. And to be clear, Vue is the JavaScript framework, if you're not familiar. I also did a bit of, yes, on your team, hooray, yeah, awesome, very cool. I love meeting other Vue friends. What else? Yeah, I've also done a bit of C++. I've at least done enough C++ to understand the code snippet you sent earlier. Enough to go, oh, I remember those, and then be sad. My time in college was very, very, very short-lived, and I was sad. I don't know. What's a catchphrase for Cars 3? Mater goes flying. I don't know. I don't remember anything about that movie. I remember it being a movie. I just don't remember anything else. All right. So those are the car movies. It's already been identified, so we're going to refresh the new tab. It's going to give me all those errors. All right. So, car movies. Let's do filter. And let's see the movies that have been released after 2016. So let's do movie dot release date or after 2010. So 2 movies were released after 2010. That was the second and the third one. Let's map it to the catchphrase. So we'll do movie dot catchphrase. I forgot some stuff here. Double colon is a common thing with C++. I think I actually had Rust in my mind with that syntax, so I'm familiar with. Am I familiar with Rust at all? I'm familiar with the name. If we're going by that standard, I'm familiar with Rust, and I understand the advantages and disadvantages, but I've yet to actually dive into Rust. It's been one of my things that I want to look into. And then finally, we can do a for each. So now we have the list of phrases for those 2 movies, and now we can do a dot for each. I'm familiar with the name. Finally, the first relatable sentence of the stream. You know what? You're the one that turned Figma into an IDE, so I don't know if you get to talk. If you know the game and you're in... Oh, wait. if you know the game and you know it's the programming language and not the game, then you're in. I do know the game, and I do know it's the programming language and not the game. I guess I'm in. Yes, I'm on a roll today. Rolling the dice, hitting Figma, or hitting Vue and Rust both times. So, we can do for each console log. The flex. Yep. So there we have it. We've mixed all three of them together. That's kind of the nice part about immutability. I will say that much. I know we've gone on quite a bit of tangent. Cowtail, you've been an awesome guest, by the way. I appreciate you joining in and jumping in the conversation. It makes streams so much better. It's so much better to have people chat with you than to just kind of sit and hang out and twiddle your thumbs and hope that you record well enough for the recorded stream. But the nice part about functional programming is that because you're making everything a function, especially in something like JavaScript where you can assign it to variables, you have those utilities built out. Once you write it once, you're able to string it together. You can call functions from other functions. You can mix and match them. I know I showed a lot earlier the, let's see if I can find it again. The append functions, you can combine them together. Like, the nice part about writing things in a functional way is that they're powerful. Like I said, they allow you to do a ton with them. Your Haskell friend might be familiar with Rust, or if they aren't, if they look into Rust, they see some nice comparisons, like how Rust has pattern matching. Funnily enough, I've not used a language that has pattern matching, yet I understand pattern matching a lot, and that is a big selling point for Rust. That's a big selling point, because I wish I had pattern matching in any of the languages that I really use. But yeah, they are familiar with Rust. They wrote a kernel in it. My friend who does Haskell is like the smartest person I know. Solemnly swear. All right. So yeah, it's been a good stream. Cowtail, I appreciate you joining us. I hope to see you on future streams. I also kind of hope to see you on our Discord. If you're on Discord, that would be cool to just be able to kick it. Yeah. All right, gang. I got some stuff going on at 6, which is in about 15 minutes here. And I have very thoroughly ran out of things to say. So I'm going to get going. Again, thank you all for joining in, and leave some comments, join our Discord, whatnot. Be around so long as you're streaming. Catch you next. I cannot speak today. I'll be around so long as you're streaming. I'll try to catch you next week. Awesome. Good stuff.